NEC Article 725.46 done addresses Class 2 and Class 3 remote control signaling and power limited circuits and discusses cable sheath protection. This section specifically states that cables entering through conduit shall be protected by a conduit bushing where the cable sheath is removed. The NFPA 70, the National Electrical Code 2020 Handbook, Section 725.46d provides further details explaining the intent of this code requirement. It explains that the protection of cables entering a building through conduit is required to prevent the entrance of moisture or gases into the conduit, thereby protecting the wires and conductors within. The code emphasizes the importance of maintaining a secure and sealed entry point for cables to prevent environmental factors from compromising the integrity and performance of the wiring system. When a cable sheath is removed to facilitate termination, it becomes crucial to install a conduit bushing to safeguard the exposed conductors. The conduit bushing acts as a barrier, preventing the ingress of moisture, gases, or other contaminants that could potentially damage the conductors or create safety hazards. By adhering to this code requirement, installers can ensure the long-term reliability and safety of the electrical system. When a gel-filled telephone feeder cable enters a building through a conduit and terminates at building entry terminals, commonly known as BET, specific installation practices must be followed to comply with the National Electrical Code. One potential issue arises when the contractor removes the cable sheath close to the conduit to divide the bundles to feed 2 columns of BET. In this scenario, a length of approximately 4 feet of conductors wrapped in electrical tape extends from the BET to the cable sheath. This particular installation method may not align with the NEC requirements, particularly concerning cable sheath protection and the proper safeguarding of exposed conductors. The NEC mandates that cables entering a building through a conduit must be protected by conduit bushing where the cable sheath is removed, as stated in Article 725.46 done for Class 2 and Class 3 remote control signaling and power limited circuits. The purpose of this requirement is to prevent the entry of moisture or gases into the conduit, thus protecting the wires and conductors within, as detailed in the NFPA 70, National Electrical Code 2020 Handbook, Section 725.46d. Based on this information, the contractor's installation method could potentially violate the NEC and NFPA 70 requirements if a conduit bushing is not installed at the point where the cable sheath enters the building. Furthermore, the exposed conductors should be protected by an approved method, such as a cable tray or raceway, instead of solely relying on electrical tape. To rectify this situation and ensure compliance with the NEC, several recommendations can be considered. Firstly, install a conduit bushing at the point where the cable sheath enters the building to provide the necessary protection against moisture and gas ingress. Secondly, utilize an approved method, such as a cable tray or raceway, to protect the exposed conductors from the BET to the cable sheath. This will offer a more robust and reliable safeguarding solution compared to electrical tape alone. Thirdly, it is prudent to inspect the cable for any signs of damage or moisture penetration that may have occurred during the installation process. Addressing these issues promptly can prevent potential long-term problems and ensure the proper functioning of the telephone feeder cable. Additionally, other sections of the NEC may be relevant to this installation, including those pertaining to the support and securing of cables, proper grounding and bonding practices, and the use of appropriate connectors and terminations. Consulting the NEC and other relevant industry standards can provide further guidance on ensuring a safe and compliant installation. A conduit bushing is a fitting used to protect wires from abrasion as they pass through a knockout in a metal box or enclosure. It's typically made of plastic or metal and has a rounded, smooth interior surface. The purpose of a conduit bushing is to provide a smooth, insulated surface for wires to pass through, preventing damage to the insulation and reducing the risk of short circuits or ground faults. It also helps to protect the wires from sharp edges of the knockout, which can cause nicks or cuts in the insulation. In the context of the question, the conduit bushing is necessary because the cable sheath has been removed. The cable sheath provides protection to the conductors inside the cable. When the sheath is removed, the conductors are exposed, and they are vulnerable to damage from the sharp edges of the conduit. The conduit bushing provides a smooth, insulated surface for the conductors to pass through, preventing damage to the insulation. Cable trays and raceways are both support systems for cables, but they differ in their construction and application. A cable tray is an open support system consisting of a ventilated or solid bottom, with side rails or longitudinal members. Cable trays are typically used for supporting large quantities of cables, such as in industrial or commercial buildings. They are available in various materials, including steel, aluminum, and fiberglass. Cable trays are typically installed overhead or under the floor. A raceway is an enclosed support system that provides a physical barrier to protect cables from damage. Raceways can be made of metal, plastic, or fiberglass. They come in various shapes and sizes, including conduits, ducts, and trunking. Raceways are typically used for supporting smaller quantities of cables, such as in residential or office buildings. They can be installed on walls, ceilings, or floors. The choice between cable trays and raceways depends on the specific application and the number of cables to be supported. Cable trays are generally more suitable for large quantities of cables, while raceways are more suitable for smaller quantities of cables. Electrical tape is an insulating tape commonly used in electrical work to wrap and insulate wires and connections. It is typically made of a vinyl or plastic material with an adhesive backing. Electrical tape is used to provide insulation and protection to electrical wires and connections, preventing short circuits, electrical shocks, and other hazards. It is also used to bundle wires together and to mark or identify wires. While electrical tape is a useful tool for insulating and protecting electrical connections, it is not a substitute for proper wiring practices and should not be used as the primary means of insulation or protection. In the context of the question, the electrical tape is used to wrap the exposed conductors from the BT to the cable sheath. However, this is not an approved method of protecting the exposed conductors. An approved method, such as a cable tray or raceway, should be used instead. Approved methods are those that have been tested and listed by a recognized testing laboratory, such as Underwriters Laboratories Incorporated or Intertech. These methods are designed to provide a safe and reliable means of protecting electrical conductors. The NEC requires that all electrical installations be performed in a neat and workmanlike manner. This means that the installation should be done in a way that is safe, reliable, and aesthetically pleasing. The NEC also requires that all electrical equipment be installed in accordance with the manufacturer's instructions. Following these requirements helps to ensure that the electrical installation is safe and reliable. In this specific situation, several key points should be considered. Firstly, the removal of the cable sheath exposes the conductors, making them vulnerable to damage and environmental factors. Secondly, the use of electrical tape as the sole means of protection is not an approved method and may not provide adequate insulation or physical protection. Thirdly, the absence of a conduit bushing at the point where the cable enters the building can allow moisture and gases to enter the conduit, potentially damaging the conductors. Therefore, it is essential to rectify these issues by installing a conduit bushing, using an approved method to protect the exposed conductors, and inspecting the cable for any signs of damage or moisture penetration. By addressing these concerns, the installation can be brought into compliance with the NEC and ensure the long-term reliability and safety of the electrical system. In addition to the specific requirements discussed, other relevant sections of the NEC may apply to this installation. These may include sections related to the support and securing of cables, proper grounding and bonding practices, and the use of appropriate connectors and terminations. Consulting the NEC and other relevant industry standards can provide further guidance on ensuring a safe and compliant installation. Grounding refers to intentionally creating a low-resistance path between electrical equipment and the earth. This is done to ensure that in the event of a fault, such as a short circuit, the fault current will flow safely to the ground, tripping a circuit breaker or fuse and preventing electrical shock hazards. Bonding refers to the process of connecting different metallic parts of an electrical system together to create an electrically conductive path. This ensures that all bonded parts are at the same electrical potential, reducing the risk of electrical shock hazards. Grounding and bonding are essential safety measures in electrical installations. They help to protect people from electrical shock hazards and to prevent damage to equipment. The NEC has specific requirements for grounding and bonding to ensure that electrical systems are installed safely and reliably. Connectors are used to join electrical wires and cables together. They come in various types, including wire connectors, cable connectors, and terminal connectors. Terminations refer to the points where electrical wires and cables are connected to equipment or devices. Proper terminations are essential for ensuring a reliable and safe electrical connection. The NEC has specific requirements for connectors and terminations to ensure that they are properly installed and that they provide a safe and reliable connection. When assessing the installation, consider whether the cable is supported properly. Cables should be supported in a way that prevents them from sagging or being damaged. The NEC has specific requirements for cable support to ensure that cables are installed safely and reliably. Also, determine if the proper grounding and bonding practices have been followed. Grounding and bonding are essential safety measures in electrical installations. Check to see if appropriate connectors and terminations have been used. The NEC has specific requirements for connectors and terminations to ensure that they are properly installed and that they provide a safe and reliable connection. Finally, inspect the cable for any signs of damage or moisture penetration. Damage or moisture can compromise the insulation of the cable and create a safety hazard. By following these recommendations, you can ensure that the electrical installation is safe, reliable, and compliant with the NEC. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. Always to energize the circuit before working on any electrical equipment. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Use appropriate personal protective equipment, such as gloves and safety glasses, when working on electrical equipment. This will help to protect you from electrical shock and other hazards. Follow all applicable codes and regulations when performing electrical work. This will help to ensure that the installation is safe and compliant. If you are not comfortable performing electrical work, it is always best to hire a qualified electrician. A qualified electrician has the training and experience necessary to perform electrical work safely and reliably. When selecting a qualified electrician, be sure to check their credentials and references. You can also ask for proof of insurance and licensing. It is also advisable to obtain multiple bids and ask the electricians for any additional information such as the overall plan for the electrical work to be done to better understand the complete nature of the project. Remember, safety is always the top priority when working with electricity. Take the necessary precautions to protect yourself and others from electrical shock and other hazards. The NEC provides a comprehensive set of standards for electrical installations. Following these standards helps to ensure that electrical systems are installed safely and reliably. Consulting the NEC can provide guidance on various aspects of electrical installations, including wiring methods, grounding and bonding, overcurrent protection, and equipment installation. In addition to the NEC, other relevant industry standards may also apply to specific electrical installation. These standards may be developed by organizations such as the Institute of Electrical and Electronics Engineers, the National Electrical Manufacturers Association, and Underwriters Laboratories Incorporated. Staying informed about the latest codes and standards is essential for ensuring safe and compliant electrical installations. Electricians and other electrical professionals should regularly update their knowledge of the NEC and other relevant industry standards. There are various resources available for staying informed about the latest codes and standards, including training courses, seminars, and online publications. Always prioritize safety when working with electricity. Electrical work can be dangerous, and it is essential to take the necessary precautions to protect yourself and others from electrical shock and other hazards. To energize circuits before working on them, use appropriate personal protective equipment, and follow all applicable codes and regulations.